Hi, Deirdre Macnamara here. In this set of slides, we're going to take a look at measures of dispersion and why it's important to know about those. Okay, so the objectives for this session. At the end of the session, you should be able to understand why you need to look at variances, and we'll go through all of that. Calculate the standard deviation. Understand the terms, the range, the quartiles and variances. It tries to measure the variability of data. So if you're looking at a set of data and you know the mean, how close to the mean were all of the pieces of information that you're looking at? And so obviously there's a very close link to the mean, and it's extremely important for the development of statistical theory, and we'll take a look at why that is so in a few minutes. Unfortunately, it doesn't really have an intuitive meaning that for example, an average has. People can kind of picture that in their heads. And it's a little bit harder to imagine exactly what does the standard deviation, but I suppose it really is how far most of the pieces of data were from the mean. It might be an easy way to work it out. So it's easy to find using software. We're going to actually calculate it out, and it's very good for getting you to understand some of the we're going to take a look at two different groups, and then we'll just sort of get an idea of how important the standard deviation is. So in the first group, or Team A, there are 3 people in this group. Mary has 1 child, Tom has 1 child, Anne has 10 children. So there's quite a difference between Mary and Tom and Anne. Okay, let's take a look at what the mean tells us about this group. So just to refresh back to what we were looking at before, to calculate the mean, we add up all the data items and then divide by the number of data items. So Mary has 1 child, Tom has 1, so 1 and 1 is 2, plus 10 is 12. So we've added all of those up and got 12. And there are 3 pieces of data, 1, 2, 3. So we divide the 12 by 3 and we get an average of 4. Okay, or a mean of 4. So for Team A, our mean is 4, but there's a huge difference between Mary and Tom and Anne. There's quite a bit of variance in this, okay? At the second team, Team B, okay, Matt, there are 3 people in the team again. Matt has 3 children, Tim has 5 children, Sam has 4 children. Okay, to calculate the mean, we add up the data items. So 3 plus 5 is 8, plus 4 is 12. Divide by the number of data items. There are 3 data items, so 12 divided by 3 is 4 yet again. Okay, so both Team A and Team B have a mean of 4. But there's quite a difference between these 2 teams, okay? So you can see that actually in Team B, the number of children is quite close. They're quite similar to each other, okay? And what the standard deviation does is it tries to explain the difference between Team A, where there's a lot of difference between the number of children people have, and Team B, where they're quite similar data items. Both Team A and Team B have the same mean, but the standard deviation will show the difference between these 2 teams. Okay, so calculating your standard deviation, or trying to look at demonstrating the differences. If, for example, we take a look at the differences here, so the mean of this particular group was 21.6. Having added up all the data items and divided by the number of items, it was 21.6. So if you look, 10 minus 21.6 will give you 11.6, and going along, here are all the differences. Okay, so we're taking each data item and we're taking it from the mean. And when you add them all up, what you get is 0. So you can't just add up all the data items. That'd be a nice handy way of doing it, but that doesn't actually work because it all adds up to 0. So we have to use another formula, and it's great somebody has developed a formula for us that we can use to show deviation. Before we go into the formula, let's take a look at some of the symbols that we already learnt in the language of maths. So this one here, the sigma sign, or the sum of, okay, so add those things up. This is the mean, or x bar, as we saw before, and here is the square root. We saw that symbol before, so the square root. Okay, and this is the formula, and you're thinking, oh my goodness, that looks a bit frightening. So S is the standard deviation, so our standard deviation is going to be the square root of the addition of all of the data items minus the mean, and the data items minus the mean is going to be squared. And n we saw before is the number of data items. Now this formula looks quite daunting, but the great thing is every time you calculate a standard deviation, it'll be exactly the same. So once you do the first one or two, gradually you'll find that they become easy. So looking at this one here, team A, we had Mary, Tom and Anne. Mary had 1 child, Tom had 1 child, Anne had 10 children. Here is X, which is all of our data items. Now looking at the formula says add up all of the X's minus the X bars squared. Okay, so X bar, the mean, okay, is your X bar. We already calculated that and we saw that the mean was 4. Okay, or the average, the mean was 4. Okay, so looking at this is our data item, X minus X bar. So 1 minus 4 gives us minus 3. Okay, take the next data item, 1 minus 4 gives us minus 3. 10 minus 4 gives us 6. Okay, so it says X minus X bar, we've done those. It then says to square all of those. Okay, so we take these and we square them. So minus 3 multiplied by minus 3, the signs are the same when we multiply them together, so it's positive 9. Okay, so this is this squared. Okay, minus 3 by minus 3 is 9. 6 multiplied by 6 is 36. Okay, so we've done this bit first of all, then we squared them. The next thing we're going to do is we're going to add them up. So we add up these numbers here and we get 54. So 36 plus 9 plus 9 is 54. Okay, so we have this bit here. We have the 54 on the top. N is our number of data items. Okay, how many data items have we got? 1, 2, 3. We have 3 pieces of data. That's what N is. How many pieces of data do you have? That's what N is. So you put in your 3 down the bottom here. So 54 divided by 3. That's what it tells us to do. Divide by 3. Okay, 54 divided by 3 is 18. And on your calculator, the square root of 18 is 4.24. Now, calculate that out on your calculator and make sure that all of those calculations are coming out correct before you move on to the next slide. That we can work through. Okay, and the first thing you have to do is work out how many data items you have. Well, there's 1, 2, 3 pieces of data, so N is 3. Okay, the mean, okay, we already calculated this. You add up, 3 plus 5 is 8 plus 4 is 12, divided by 3 is 4. So the mean is 4. Okay, you write them in here. Okay, so the first thing it says to do is X, each of the data items, minus the mean. So 3 minus 4, 5 minus 4, 4 minus 4. Then take these ones here, square them and put them out here. Next thing to do is add them up. Add up all the items here and get your total. It's this total here that will go on the top up here. On the bottom will be your 3. Do that calculation and then hit your square root. Okay, try that out yourself before you hit go forward or hit pause. Okay, so looking at this here, we've got our 3 and our 4. 3 minus 4 is minus 1. 5 minus 4 is 1. 4 minus 4 is 0. Now we take all of these and square it. Minus 1 multiplied by minus 1 is 1. 1 multiplied by 1 is 1. 0 multiplied by 0 is 0. That's them squared. Okay, add all of these up. 1 plus 1 is 2 plus 0 is 2. So 2 is this bit here. We put the 2 on the top. We divide by n, which was the number of data items. 1, 2, 3 pieces of data. So 2 divided by 3 is 0.66. And on your calculator, the square root of 0.66 is 0.82. Okay. Okay, again, try this one out and hit pause. Okay, again, I'll just work through the first one here. The mean of this group was 3. The number of data items we had was 1, 2, 3, 4 pieces of data. Okay, so it's 2 minus 3 is minus 1. Minus 1 squared, minus 1 multiplied by minus 1 is 1. Do the same for these lines here, then add them all up to get 14. That's why we ended up with a 14 on the top, divided by the number of data items, 1, 2, 3, 4 pieces of data. So that's why we have a 4 down the bottom. And then calculate that out. 14 divided by 4 is 3.5. Square root it on your calculator and you end up with 1.9. Here's team D. Hit pause and try it out. Now you'll see all of these data items are exactly the same. Okay, so our mean is 4. 4 minus 4 is 0, 4 minus 4 is 0, 4 minus 4 is 0. Square them when we get 0, add them up when we get 0. 0 divided by 3 is approximately 0. So the standard deviation, or the rough deviation in this case, is 0. Here's another example. 5 Irish guests have arrived at the hotel. With them, they have the following number of suitcases. Okay, calculate your standard deviation. Okay, and here's your answer. Here's another example with American tour group. Hit pause and your answer. An Italian tour group. Hit pause. Okay, so looking at this particular one here, okay, you can see this is the number of pieces of data over here. This is the raw data that we're working with. The mean is 21.6. X minus 21.6 gave us these numbers here. We square them and then we total them. Okay, so the number of data items is 10. So, and the square root of that is 11.77. Now, if we changed some of these data items, okay, the average is 21.6. If we got rid of some of the bigger data items, what happens to the standard deviation? Okay, so this time we reduced some of the data items just to see what would happen. Okay, so we brought that one down. Okay, and you can see we've reduced them. And this gives a standard deviation that is much lower. Okay, so it's 6.26. So by reducing the variability, you can see that the standard deviation also reduces. Okay, moving on now to other measures of dispersion. You've got variance, and this is actually the square of the standard deviation. Really, I just want you to know what that term is. Okay, it's very closely related to standard deviation, but it actually is just the square. So you just multiply it by itself, and that's what the variance is. We're doing descriptive statistics at the moment, and it's used more when you're analysing the data rather than when you're describing the data. The range, we've come across that one before. So your range is the difference between your maximum and your minimum. It's a very simple thing to calculate. So it's often a good idea just to provide the maximum and the minimum as well. Measures of dispersion, you've got quartiles. So these show you the two values which are at the bottom quarter and the top quarter at either end of the data. Okay, one of them is 25% of the way through the data, that's the first quartile, and then the other one is the 75% through the quartile. We already saw the 50% one, and that was the median. Okay, so they're quite closely related to the median. So you line them all up and you find the one at the 25%, you line them up and you find the one at the 75% is one way of doing it. There's a number of you can calculate it. So in summary then, it's not sufficient just to measure location or an average. It's also important to understand the dispersion or the spread of the data. How far is all the data from the measure of central location that we've already established? And the standard deviation is the most widely used measure, but it lacks an intuitive meaning. Okay, as a general sort of rough guide, it means how far each data item is from the mean, but it's not exact